availability on FortiGate Firewall. Welcome again to Netlabs Hub. In today's video, I'm going to show you how to configure high availability on FortiGate Firewall. In this, using the active-passive mode. So this is the topology that I'm going to use. At the end of this video, you are going to understand how high availability works in active and passive mode, and how the FortiGate clustering protocol is used to sync configurations or status of individual firewall to other firewall acting as passive or in standby. So the two interfaces in between the firewall, these are the heartbeat interfaces used to exchange the configs or the status between the firewalls. Then the port facing the internet and the port facing the LAN, the two are going to serve as the monitor interfaces. For you to achieve high availability, there are requirements for you to consider that the two firewalls must be of the same version or the same hardware architecture or hardware features. Then the heartbeat interface should be the same. Then also the license should be valid. From there, you should understand that high availability on FortiGate Firewall is a redundancy feature that helps to eliminate a single point of failure in an enterprise network environment by providing alternative backup to network downtime in case maybe primary fails. So on this topology, I'm going to assign IP addresses on the interfaces, then access the firewall in the graphical user interface, then to enable the high availability on that, and automatically it will sync with the other firewall upon enabling. You should understand that also priority is what makes a firewall to be in standby or active. The higher the priority, the higher the chances the firewall to work as active or a master. Also, for the firewall to become a master or active, it depends on several factors. It depends on the device uptime. The uptime, the higher the time the device has been up, it gives it a precedence for it to become active or a master. Then the monitored interface. If the health check wins, then it gives it the master capability. Also the device priority. Priority ranges from 0 to 255, whereby the higher priority, the higher the chances the firewall to become the master. So I'm going to configure this firewall to give it a higher priority so that it can serve as the master. I'll right click on the console, then access the firewall. In this scenario, port 1 is facing the internet, then port 1 is facing the internet config system interface, then edit port 1, set mode, it is going to operate on DHCP, then we set allow the port, that is enough, then set role 1, then we set alias 1 1. So then next, edit port 2. Port 2 is a LAN port. Set mode static, then set IP 192.168.12.1. This is the gateway for the firewall. On the secondary firewall, I'm not going to assign any IP on that interface. It will just sync. Then set role, that is LAN, then set alias LAN 1. Then set allow access. We enable ping capability on this. Then from here we configure the management interface, which is port 5. Set mode, it is going to operate on DHCP. Then set allow access FGM, HTTP, HTTPS, Telnet, SSH, then ping. These are the protocols that are allowed on this to enable this interface. Once we do that, we set the host name for the firewall. So set host name. This is FGT primary. Then we enter. The moment we enter, we will verify whether our interfaces have been configured, those that we set to receive IP address automatically, and those that we set to receive the to get IP statically. So we will use diagonalize IP address list. Then we will see. We find that the management interface has received this IP. Then this is the LAN port. Then this is the IP that has been received on the WAN port. So this section here, let me name it. So this one has received this IP. This one has received this IP. Then the interface, the management interface has received this IP. So this IP is, my server is this one. This is the server that I'm using, the GNS3 VM server. So I'll go direct to the browser, then access that firewall in the browser. So this is the primary, but there is something that we should expect. The management interface is going to be changing. So once the firewall boots, it might find itself to a different IP. So you should keep on checking on that. But in a real environment, you can still retain the management in case the firewall boots or reboots. So I'm using the version, FortiGate version 7.0.15. You can see this is a pre-evaluated license. So the two versions must match here, the firmware versions. So once we confirm here, we will go directly to the network section and check the interfaces. So you see, these are the interfaces. This is dynamic interface. Then the WAN port is also dynamic interface. There is no IP configured on the heartbeat interface. So once we do that, we'll just enable the DHCP on this LAN port. We disable this because it is off. So we give it 50. Then we are good to go. So once we do that, we set a static route. The function of static route is just to define the path through which the traffic will follow to the internet, so that static route will just help to direct or guide how this traffic will reach this particular internet here. So to create static route, we just create, we go to the network. Under network, there is static route here, and then we leave this one the way it is. It means any node on the internet will be accessed. Then our gateway is this gateway, this IP here. This is the gateway. So this IP is for this particular port here. So the gateway is this particular point here. In real sense, now that this being an open switch, the gateway is this particular port. So we just, and it's dynamic, there is nothing we're gonna type here. We just choose that particular one port, then immediately you will see this select dynamic, then it will give you a great IP address on this particular. So that is done. Once we create a static route, we come on the policies and objects, then configure the firewall policy now to allow traffic. The function of firewall policy is to allow traffic from one location to the other location of the network. So in my case here, it is allowing location from LAN A here up to the internet. So through this firewall. So the moment I will enable high availability, it will just sync, and all these things that I have configured on this will be synchronized on the other end. So step by step, at the end of this, you are going to get it all. So we create new. Then this is LAN to internet. Then my incoming port is the LAN port. Then outgoing is the WAN port. Let me show you. This is my incoming. Then outgoing is this port. Leave alone these heartbeat interfaces have a reserved function. Then the source is all. It means I'm going to choose every IP within this LAN subnet. Then destination is everything on the internet. Then our key point here, you enable all session. Then we generate logs upon start of the session. Ensure NAT is enabled because I'm using NAT simulator. So at this point, traffic can move comfortably from this. So IP DHCP. You see DORA. The moment you see DORA, it means that it has successfully connected to the DHCP server. So now we ping. We can ping Google. Still, I hope it will work. You see, I can ping Google DNS. You see, it's working. Initially, it was not working because there was a path for traffic to follow, but it was not allowed. But you realize there are drops here. So we stop this. So at this point, I have configured everything on the primary firewall. So on this firewall here, I'm going also to assign the interfaces as I have done it on primary. So you set the admin account, then configure system interface. After there, edit port 1. You set mode DHCP. You set the services that can be accessed on that port. Then set alias 1, 2. Then next, edit port 2, set mode. There is nothing we can do on port 2 because it will sync directly from port 2 of the primary firewall. So we just configure the management interface port 5, but once I enable high availability, the management interface for the 2 firewall will be 1. So we set mode DHCP, then set allow access HTTP, HTTPS, FGM. So that is enough. Set alias MGT2. Config system global. We set the hostname. Hostname helps to identify the device on the network. Hostname. Then FGT secondary. So So we are done that way. We use diagnose IP address list. You see it has received 68. Then our one port is this one. Just up here and then paste here and then that is it. So that this is the IP for this. So I will use 67 here, but before I access the next firewall, the backup firewall in the browser, I'm going to extend my idle time on this firewall so that it stops. It does not log me out. So 192.168.10.68. This one was 67, then this one is 68. We don't save. We enable. Then immediately we extend the idle time. So that the firewall does not lock us out. We remain in session. So on this secondary firewall, what I'm going to do, I'm not going to create anything. The LAN interface, I'm going to leave it the way it is, because it will take, once it performs synchronization, then whatever that is on primary will be found on this, and they will function on the same interface. So here I'm going to now start configuring high availability. High availability is a system feature, so you will find it under the system tab here. You will see it's here. And remember, I'm on the primary firewall. This is the modes that I started explaining earlier, that high availability can function through a standalone mode or active. In this case, both of the firewalls available in the cluster are all active. There is no one that is offline or in waiting for the other to fail so that it can take action. Then there is active passive, so that there is one that is the master or the hub, then the others are just waiting for the master to collapse so that at least they can also perform the tasks. So in this regard, active passive mode is the one that I'm going to use for this. But I'm going also to create a next video on this particular mode, active, whereby both firewalls are in the same state. And I'll also explain and show you what happens when it operates this in relationship to traffic. So you set the priority to the highest. I will give it 250. Then the cluster name, I'm going to give it Netlabs. The cluster name, it should be the same, so I'm going to name it Netlabs Hub. The password to authenticate the firewall in the cluster, I'm going to give it that one, Fortinet. So then I will enable session pickup so that when one fails, the other will automatically pick the session. Then monitor interface. In this case, monitor interface is the port facing the internet, then the port facing the local area network. When it comes to heartbeat interface is port 3 and port 4, according to this topology here. These are the heartbeat interface, and this port and this one are monitor interface. So they will be checking whether this firewall is down or not. It will relay the signal to the other through the FortiGate clustering protocol, FGCP. So at this point, you leave everything the way it is, then you save. The moment you save, this file will reboot. So you see, So as this one reboots, let me also enable the high availability on the next firewall, that is the primary, the secondary. So you choose the same mode, then priority you can just leave it the way it is, or we can give it 150, no big deal, because my primary is functioning at 250. So here, ensure that the cluster name is the same, Netlabs Hub, then the password is also the same for authentication purposes, or else your cluster will not be up. Then enable session pickup. Then at this point, select your monitoring interface, then port 2, then heartbeat is there, port 3 and port 4. So at this point you are done, then you save. The moment you save, you see at this stage the firewalls are trying to sync to each other, so there is nothing we can do. We will use the CLI. You can see here. Let me just make it bigger for you to see the changes. You can see the changes, that secondary external files are not in sync. So synchronization has not happened at this stage. You see, it is trying to negotiate. So you can say show execute reboot. So I want to reboot this firewall. Same applies to this. This one has finished rebooting. When you check diagonalize IP address, it has changed, I'm sure. You see, it has jumped to 70. So no, from 67 now it has taken this IP address. So this is going to be my management IP address. Now you cannot get it at this 67. So you see, I want you to check and master something here. That IP address, it is the same. So the moment I access that IP address, you will find that the secondary and the primary are all having the same naming. So I'll just stop this, then access this firewall here, also in the browser. You can see this is the FortiGate number 2. The system, you can see it is starting. So let's give it time. At this place, let's concentrate on the primary, then see what happens. We can go to the log report, then come on the events, then check high availability. You can see here that virtual cluster member started moved, you see. Then virtual cluster detected member dead. The time it was rebooting, this was the log that was logged. Then the yellow, you can see the yellow part here. It means that the heartbeat packet lost. So you see, the heartbeat interfaces from the other end was trying to sync the packets or send traffic, but it was not successful because the other firewall was off during the boot time. You see, these are the statistics on that. You can see here there is no synchronization at this part here. Once there will be synchronization, it will be a tick. On this firewall, we can say show system high availability status. You can see this is the group name. Then this is the mode in which the firewall firewalls are functioning, that is active, passive. Then this is the password that I set. It is in hashed or encrypted. Then heartbeat HBDEF, it means heartbeat interfaces on device port 3, then port 4. You see? Then 0 means that the priority is just the same. Set session pickup enable. The session is enabled so that when one fails, the other one picks up. Then override here. You see this statement here. By default, override is disabled so that this prevents preemption. Preemption, it means that when the master or primary firewall boots or recovers, it does not aggressively snatch the active role from the backup or the secondary firewall. So that one, we try to disable override to ensure that there is no flapping on the network. So you should understand this one. If I do enable this one, it means that when primary firewall boots, then because it has the highest priority, it will just snatch instantly the role of active from the secondary. So that is it. Then my monitoring interface are that one. Show system. I have included here all the commands to verify. You see, these are the commands to verify the high availability. You can say diagnose system. You see, these are the things that we can do. Status. We see these are the statistics on that particular. We can repeat the same, then see the status. Traffic, you see, then activity high availability ID is this. Then debugging zone, you can find it here. It will show you whether it is primary or secondary. These are the serial numbers. So at this point, you can see that there is synchronization that is about to happen. So we will do this. We will access the second firewall here. You can see these are the statistics. Still, it is trying to sync, but so we log in, then diagnose IP address list. Then you find that it is also having the same IP address as the primary. So we copy the same the same IP address, then we paste in the browser. You see this is primary here. Then you see it is also named primary, even though we named it secondary. It means that synchronization has now happened. You see this place, there is a tick synchronized. So this two firewalls are being managed by the same interface. It means that what I configured here is now available on the other firewall. So if we check on the interface, the way I named my interface, you can see LAN 1. Remember, I did not configure anything on the LAN port on the secondary firewall, but you see, these are the configuration. It has synced with the primary. And remember, you see here, this is the traffic that is going. So that traffic is this traffic that we tried to send earlier. So we can repeat the same. You see, we can just ping to the Google DNS direct. So as this traffic is going that way, we can check that when we refresh, this one will increase those bytes, these bytes here. These bytes, you see, these are the bytes. So when we check the static routes, I'm on the secondary firewall. Whatever that was configured on this end here, this one is also here. So this one means that when this computer tries to communicate to the internet, when this particular path is down, it will tend to take the alternative path. You see? When this firewall and this one are totally down, then traffic will have a timeout on the traffic. But when one is up, it will take over to route the traffic to the internet. So in this regard, let me show you the events, the logs that is happening on the... First of all, we check the forwarding traffic. We refresh this. You see? This computer here enabled DHCP. So this computer is trying to access Google. You see, there is a US flag here. It means that Google is based in US. Then these are the results. The session is accepted due to the power of the firewall policy. You see? When we click there, you can get that it has sent how many bytes? Almost 70 bytes. So it is logging all this traffic every time. So when we check on the events for high availability, you see, cluster member state moved. So it's up. So we can execute, then reboot. So you see, the moment I have rebooted one, the same have just rebooted. So because they are sharing the same interface for the management. But remember, this one can be changed in the real environment. Now, the moment I rebooted the primary, the secondary has taken over. Let's check the traffic. Still the traffic is able to go through the internet. So I want to test something. Let me now stop this file. I'll just suspend. The moment I suspend, then we check the high availability here. What happens when I suspend that particular firewall? It was the current primary, but now I have suspended. We will have some loss of packets, but upon this firewall coming up, you see, so it has lost the connection. So what we do, we just access this, then diagonalize. It is in rebooting mode, so we check this one. We log into the admin of the primary, then diagonalize IP address. You see it has received which IP? There is not yet IP received. It has received 70 still. So we will just, the moment you log in with this 70, with this IP address, you see, the moment we log in, it will change from secondary to primary, and the traffic will now have the opportunity to go to the internet without drop. You see, it's coming. So at this point, destination was not reachable. But remember, the moment I have just logged into the primary firewall, it has taken over the role. Now, this particular firewall is suspended. The one that used to be the primary initially, this one I'm pretending it to maybe to have, it is out of the cluster. So I have this one. Now traffic is not going through this way, it is going through this particular path, through the primary. So with that regard, you can see traffic is up now, even though there is downtime, but still traffic. Let's just start afresh. Ping 192.168.122.1. You see, this is the gateway for the internet. There is no drop. There is no drop, but you realize here, this, I have suspended all the heartbeat interface from this section. Then let me now show you the high availability. You see here it is primary. So in this, we'll just come on the system. At this point, I want to show you how my cluster is looking. You see there is no drop. So let me unsuspend this. Show system. You see? Then diagonalize system. You can see the MAC address of all the ports that are associated on that, and the serial number you can see here. This is the serial number for the secondary, then this is the serial number for the primary with its related interfaces here. Diagonalize system, then you can see if these particular numbers are matching, it means that synchronization has happened successfully. So at this point, we have all firewalls up. So you see the status synchronized. When you check here, you will get that priority here. So priority is one of the elements that is used to elect the primary or the secondary firewall within the cluster. So that when this one goes down, even if it has high priority, this one will pick. But when you enable the override, when override is enabled, when this one finishes booting, it will just take the role of primary from this particular secondary firewall automatically without negotiation. So, and that one will lead to network flapping. So to avoid that, always disable the preemption, that is the override. So that at least when this one finishes or recovers from booting, it will just also stand. It will be standby as a backup or as a secondary firewall to wait this particular secondary firewall to fail so that it can take over its role. When we check at this, these are the sessions, then these are the throughput or the bytes, the traffic that is passing through this at the moment. So at the moment, traffic is passing through this path. You can check, you see, much traffic is passing through the secondary firewall. Because When this one was down, this one assumed the role of primary. So when we stop this firewall, I have stopped it, then refresh this section here. You will notice something. You will notice something. The moment I stopped, there was 2 time down for that traffic. Then after that, still traffic continued to flow. Because there is 1, the path automatically changed to this section, you see. It used to go through this particular path, but now it is using the alternative path. So when this one goes down immediately and it is the primary, it will lead to a slight loss of the packets of the traffic. Then rest packets will be assumed using the alternative firewall on that. You can see traffic still it's going, there is no drop. When we check on this in the cluster, I just have primary. You see now traffic is going through the available firewall, the primary firewall here. So it is using this firewall. When I enable both, when I unsuspend or this one recovers from, maybe it finishes booting, then you will notice that my cluster will have an addition. There will be 2. So you see at this point, this one is stuck because they are using the same management IP address. You can see still traffic is going. So this scenario, high availability, is one of the best scenario in network environment to implement redundancy, in that when one firewall is down, the other one takes control of the traffic at that particular point. So the moment it finishes booting, you will understand. You see, it is scanning. So the moment I stopped that firewall, I interfered with its file system. So during boot up, it has to scan all the logs, the firewall, then it comes up into the cluster. So you see at this stage, I expect you see traffic still is going through the primary firewall here. Even if that particular second firewall comes up, it will just join the cluster. It will not take the role of the primary from the current firewall, you see. So this is it. So after it has finished recovering, it has just joined the browser without snatching the role of primary from the current firewall that is in control. So this is how we implement high availability on FortiGate Firewall. Feel free to subscribe to Netlabs Hub if you feel this particular lab has enabled you to learn something new. In my next video, I'm going to make a project on the high availability, but where these 2 firewalls are acting as active and active. So that is not a recommended method, because it makes when one goes down, the other one also goes down. When one firewall goes down, it does not affect the other, but when 2 firewalls totally goes down, then there is total failure. So thank you so much for your time on this particular tutorial. Keep watching, like, comment, and share. Thank you.